Okay, so this is part two. This is part two of deriving using product rule. Okay, so we gotta find f prime of x, right? And we're gonna use the product rule because we're multiplying. So first, to find the product rule, you gotta find your f. So this is my f, and then this whole thing is my g, right? So let's distinguish it. F is cube root of x, and then g is square root of x plus 3. I gotta find f prime, so we rewrite this in power form. That's equivalent to saying x to the 1/3. And then you could take the power rule to find the derivative. So it's 1/3 x, and then 1/3 minus 1, which is the same thing as 3 over 3, which is negative 1 minus 3 is negative 2 over 3. So this is going to be negative 2 over 3. How do I write this in positive power? I can rewrite that as 1 over 3 x to the positive 2/3, and you can rewrite that as 1 over 3 cube of x squared. Good. So that's how you write it in the first power. This is my f prime. Let's find the g prime. So we know the derivative of constant is just constant. This one is going to be derivative of square root of x is 1 over 2 square root of x. So how I got that was, you can rewrite x to the square root of x is equivalent to saying x to the 1/2. Then you take the power rule, which is 1/2 x. 1/2 minus 1, which is 2 over 2, is the same thing as 1. Negative 1/2. Rewrite that as 1 over 2 to the x to the positive 1/2. And you can rewrite that as 1 over 2 square root of x. Okay, that we found our f prime and our g prime. So now we just gotta find the product rule. So the product rule is fg of prime, which is f prime of g plus g prime of f. So f prime, what's my f prime? My f prime is this, right? This one or this one? For right now, I'm going to use the power rule. I'm going to put it in power form, not radical form for right now, because you'll see what I mean. You'll see. So f prime is 1 over 3x to the 2/3 powers, positive 2/3, and then times it by g, and we know that g is, what is g? G is square root of x. So times it by square root of x. Wait, it's just square root of x? No, g is just square root of x plus 3. So times it by square root of x plus 3. Plus g prime of f. So what is my g prime? Is 1 over 2 square root of x. But I will rewrite that, instead of radical form, I'm going to write it in power form. So it's going to be 1 over x to the 1/2, right? That's the same thing as 1 over 2 square root of x. Times it by f, which is just the cube root of x. Good. Let's see here. Let's clean this up. So this one is going to be square root of x plus 3 divided by, I'm going to rewrite this in radical form, so it's going to be 3 cube root x raised to the second power. This one is going to be just cube root of x over 2 times square root of x. So we're adding fractions, so we need a common denominator. So what do you think my common denominator is going to be? We have this and this. The common denominator is going to be 6x to the 2/3 power, right? This is my common denominator. So for this part, what do we have to multiply top and bottom by? Just 2, right? 2. And then over here, what do we have to multiply to get 6 to the x to the 2/3 power? You can multiply that by, let me rewrite it in power form, x to the 1/2, right? You just have to multiply this by 3x to the 1/6. Because remember, when you're multiplying powers, you're really adding. So it's like saying 1/6 plus 1/2. That's going to be 3 times 3. This is going to be 4/6. And when that reduces by, it's 2/3. So that's why I'm multiplying this by x to the 1/6, and then I'm multiplying this by 3 to get 6. So multiply this by 3x to the 1/6. So this is going to be, the numerator is going to be 2 square root of x plus 6, right? Now, when you multiply this, I can rewrite this as cube root of x is the same thing as x to the 1/3. So when you're multiplying exponents, you're adding. So 1/6 plus 1/3 is, get a common denominator 6, so multiply this by 2. So this is going to be 2 over 6, which is the same thing as 1 over 6 divided by 1/3. So this is going to be plus 3 to the x to the 1/3. I mean, not 1/3. Wait. So when you're multiplying exponents, you're adding. So it's 1/6 plus, this is going to be 6. 6 divided by 2 is 3. I'm trying to think, did I make a mistake? So this is 3x to the 1/6, and then cube root of x is the same thing as 1/3. This actually should be, when you add this should be 3 to the square root of x. Let's see, where? Six. Oh, there I go. This is where I messed up. 2 plus 1 is 3. 3/6. Rewrite that as, reduces to 1/2. Duh, that's where I made a mistake. So that's like saying that's like saying x to the 1/2, right? Times it by 3. So 3 to the x to the 1/2, that's like saying 3x to the 1/2. That's your final answer, and that's equivalent to saying 3 to the square root of x. There. all over, by the common denominator, 6x to the 2/3, but we can rewrite in radical form, it's going to be 6 cubed x squared. That's the same, this is equivalent to that, right? Now, you just combine like terms. So you can combine this term with this term, right? So your final answer is going to be 5. You just, when you're combining these, you add the coefficient. 3 plus 2 is 5. And then this, you're just left with the radical x. And then the leftover is plus 6. All over 6 to the radical 3x squared. Okay, you could put it in this form, but the book actually wants it in power form. So how would I rewrite this in power form? You can write square root of x as 5x to the 1/2. The 6 just stays the same. All over. How do I write this in 6 to the cube root to the 6 cube root of x squared? In power form, it would be 6x to the 2/3. So this is your final answer. So this is example 6 of the derivative using the product rule.